Okay, can you see the next slide?
Yes.
Yes.
Okay, in this part, basically, just a short 19 slides, but maybe less. And in our second part, we will try to calculate, the main important thing is we try to calculate voltage current of simple RL, RC, and also RLC circuit. And before we get into that one, we will be introduced with a term called root mean square or RMS. This is very important. I also put a video on this root mean square issue in your e-learning. You can have a look at that later on. And also impedance, we have been introduced, but here we try to expand our knowledge a little bit more in terms of connection in our AC circuit. And also to analyze, we need Kirchhoff law or sometimes simple Ohm's law to calculate our or to analyze our circuit in AC. All right, what does it mean by RMS? Here it says that the effective value for both current and voltage take the form of the square root of average. For example, basically RMS voltage is the okay. Let's say we have sinusoid over here, and the voltage up here is the maximum voltage for here is 240, and the effective 240 is not constant value. It's alternating with respect to time. Sometimes we have 240, sometimes we have negative 240, and sometimes we have value between those two values, positive and negative value. And if you, for example, if you put, do you know what is multimeter? Voltmeter, do you know?
Yes.
Yes, multimeter.
I know.
Multimeter can measure the voltage,
Volt, ampere.
current, ohms, like, and also conductivity, right? And if you turn on the multimeter mode into voltage or voltmeter, and if you try to measure this kind of waveform, for example, if you go into your socket outlet, you know that your socket outlet should produce 240 volt. That is Malaysia standards. And if you put a multimeter or a voltmeter, AC voltmeter across live and neutral, you cannot get this 240 because the voltmeter actually gives you the effective value, the constant value, effective value of your AC voltage. The effective value of AC voltage is given with is slightly lower than that, so it's slightly something which is within this value, and this value is basically given by 240 divided by square root of 2. So this is the effective value. So in any calculations of AC circuit, normally we will use RMS value to calculate, to use, for example, to calculate, to analyze our circuit, calculate current, voltage or whatsoever. We will use RMS value, which is the effective value of either voltage or current. But previously, if you look at example that I show you in Thursday class and maybe just now, I never bother about the RMS value. I just I just use the peak value or the maximum value. But basically, if you would like to calculate or you like to analyze your circuit using either Ohm's law or whatever tools that you have, Ohm's law, Kirchhoff law, node analysis, mesh analysis, and so on. First thing that you need to do is you need to convert your voltage into an RMS value. So that is very important. However, in your case, maybe I'm a bit lenient on that. If you calculate your, if you analyze your circuit using peak value also can, you analyze using RMS value also can. But please remember, in practical, we always use RMS value, because in real world, if you try to connect your voltmeter into your power outlet, you never get the peak value or the maximum value. You will always get the effective value or the root mean square value or RMS value. So that's what's about RMS. And you can always read this one later on, because RMS is given by the integration with respect to time. Here time is the period. All right, a period of the sine wave. And to cut short the definition of RMS, because this one can be read later on, I just explained you the practical implementation or what you're going to expect in practical. If you, for example, if you see that your power outlet is like 120 volt, means that that one is not your RMS value. Okay, you need to find what is the RMS value by divide it by one square root of 2. And sometimes if you look at your for example, your equipment always rated based on RMS value. If the equipment tells us about, okay, this equipment will operate from 220 up to 220 to 240, for example. So that range is basically your RMS value range for that case. All right. Later on, we move on into voltage and current and voltage in phasor. I think this one already been explained earlier to analyze between voltage and current with respect to the phase shift. So here, I think I missed something over here. Plus theta. Never mind. But in this slide, you already seen this slide previously in lecture note part 1. I think lecture note part 1 has better explanation on this one. All right. If you look at what I've explained earlier, if you try to convert from peak value into RMS value, means that you need to include the influence of the one of this square root of 2. For instance, if you have a voltage, for example, here you have a voltage of 25 sine omega t. Okay, this 25 can also be translated into cos, which is 25 cos omega t minus 90. You can write your voltage in RMS phasor terms like this: 25 divided by square root of 2 with the angle of negative 90. You can also use this one, okay, this waveform, to calculate your phasor representation, phasor form. In phasor form, with respect to RMS value, okay, RMS value for this one is phasor form. Okay, given by 25 divided by square root of 2 with the angle of 0. Okay, please remember that these two is the same. Okay. However, these two is not the same. Why? Because this one has 90 degrees, this one has 0 degrees. So that's why it's not the same. It is the same, basically it is the same, but in some sense that it is not the same. It's quite hard. For example, if you have a voltage, for example, here we have Z. Okay, I put Z like that. Okay. Okay, this is I of T. This is P of T. Okay. If you use this kind of reference or this kind of if you use voltage in a cosine form, okay, if this is in cosine form, means that in order for you to write I of t later on, okay, for example here I of t, I can be calculated using V divided by Z, and you can write I of t later on based on the voltage, the current magnitude over here, and also the I, and also the angle over here, I. So we're gonna have I cos omega t plus or minus with the angle you find here. Okay. Remember that if you are using cosine form as the reference of your voltage or as the equation of your voltage, remember that the equation of the current must also in the form of cosine. And here, if you use sine, okay, if you use sine to represent your voltage, means that I of t, later on, I of t should be also based on sine. I sine omega t plus or minus theta I. And you know that to get these two values, I and theta, it is given by I equals to V over Z. And if you solve these two, it will give you the magnitude of I and with the angle. And these two components, I and theta, is the value you see in the equation of sinusoid for your current. And remember, if you use sine, means that your current later on, when you try to calculate, is also sine. If you use cos, your current also in the form of cosine. And that's the difference that I try to explain to you guys. If you look at the magnitude, here the magnitude current is the same because we have 25 divided by square root of 2, same goes to here. However, if you try to get the angle over here, angle for sine waveform is given by 0, and 0 divided by angle down here for Z will give you, for example, one value. And for here, negative 90 degrees, if you try to divide with the angle of Z over here, will give you another value, which is the difference or the phase shift is about 90 degrees. So that's what the difference is all about. So please remember to cut or to minimize your error. If your voltage in cos, make sure your current also later on in cos. If your sine, if your voltage or current in sine, make sure your current or voltage later on during your calculation, when you try to write it back, make sure it is also in sine. All right, that's for voltage and current phasor. I think this impedance part already been discussed earlier about the composition of impedance, where it can be split into two. First one is the real component, and second one the imaginary component. Real component is the resistance value, the imaginary component is the reactance, and the reactance can be represented by component of inductor and also component of resistor. All right, this is something which is you will not find in your textbook. This is something that I think I summarized from from the characteristic of the voltage and current relationship. If you try to think about the relationship between voltage and current in AC circuit, please remember about this word CIVIL. For example, here, if my if I have circuit, okay, consists of resistor and capacitor, or some circuit consists only capacitor. So I will get into this red box, and to get to know what is the relationship between current and voltage over here is given by these three letters CIV, where here for capacitor, I would say that I will always lead the voltage by certain degrees, depends on whatever value of your impedance angle over here. And for circuit consists of resistor and inductor. Okay. Same goes as for the circuit consists only inductor. So I will focus on this blue box. This blue box says that VIL for this kind of circuit, if I try to analyze what is the relationship between voltage and current, here current always lag the voltage by whatever degrees over here. That's why I put it here by theta degrees. And voltage, you can also write it in the opposite way. You can also write it as voltage always lead. So here, look at the red box. I comes first and later on V. So that's why I lead. This is not C, this should be V. Erase this first. This should be V. I lead V by theta degrees. And if you want to write it in opposite way, maybe you can write it V lag I. In this case, we consider V as our reference. Okay. In this case, we consider I as our reference. Okay. Same goes to the one that you see in the blue box. In the blue box, for example, we have resistor and inductor, or only inductor in your circuit. It is always the relationship between the current and the current always gives us this kind of relationship where the current always lag the voltage by certain degrees. Certain degrees mean you need to calculate the value of vector R and X over here. If you look at the words over here, VIL means that V will come first before I. So that's why we say that I lag V by that degrees. So here, if you write this statement, you are considering that V is your reference. And again, if you look at the word VIL, means that V comes before the current. You can also write like using this form, this statement, where V is leading the current by certain degrees, depends on whatever value of your Z angle. So here you are considering your current is your reference. So there are two ways to write down the statement of voltage and current relationship, whether by adopting V is your reference or current is your reference. However, you need to really pay attention or carefully analyze the characteristic of the circuit itself. If it is purely C or RC circuit, for example, circuit you see over here is RC circuit, you need to remember that always the relationship of voltage and currents always given by this letter CID, and for L or RL circuit is given by this letter VIL, and if you combine is given by civil. This is something that I learned during my undergraduate time, which is not in your textbook. Maybe I don't know about you, but for me this is the way I understand the relationship and of voltage and current, as well as I try to what do you call it, to check my answer whether it's correct or wrong, because I know my answer should follow this kind of voltage current relationship. If I have, for example, if I have RC circuit, means that my current should always lead my voltage. And if I have my the circuit itself is RL circuit, my current will always lag my voltage. That is something that a reference to me in order for to check my answer whether it's correct or not. Okay, I don't know about you. Maybe you have your style or your approach how to remember that one. Anyway, we move on into a phasor diagram. I think this one is also been described previously about how we draw the phasor diagram, and maybe later on we will get to know better if we have a look at examples. Okay, for phasor diagram, as I think this one also been, this is just information already been described previously. All right, we move on into example for purely L circuit. Okay, if you look at this example, you don't have the circuit. However, you need to read carefully the question. The question says here that 500 millihenry inductor applied 115 volt with frequency of 60 hertz. Means that your inductor value is 500 millihenry and voltage applied here is 115, and the voltage is not represented in a sinusoid form. Means that the value that you see over here is basically your RMS value. This is RMS, BRMS, because it's not represented in sinusoid. And the value that you see over here, 60 hertz, this is your frequency value of your voltage. The frequency is very important in order for you to calculate the reactance and later on to calculate the current flow in the circuit. So here is step by step how you calculate it. First, you need to calculate what is XL. XL is given by 2 pi FL, and you know that frequency is 60, just substitute it here 60. And after you do the mathematics, you will find out that XL is given by this 118.5. And remember, since this is a circuit, this circuit only consists of inductor, so ZL is given by J XL. So remember, for XL, always the J here always positive. And since the J here is always positive, the imaginary operator here is positive, you will have a positive 90 degrees. This is like a quick check for you guys. But if you don't know about this, maybe you only know about ZL is given by J118.5. You can put this value in your calculator or in the website that I showed just now, and um, find that the vector of ZL is 118.5 with the angle of 90 degrees. Let me show you what I'm talking about. All right, here, okay, now we know that we need to convert from rectangular to a polar form. And the real part value is given by 0, and the imaginary value is given by 188.5. So if you try to convert, it will give you 188.5 with the angle of 90 degrees. So in other words, if you don't have this real component, means or in other words, you only have the imaginary component, this J operator means 90 degrees. Let's say, for example, let's say we put it this way, maybe negative J118.5. So what happened over here? It will give us 270, or in other words, this is negative 90 degrees. So if we have negative J, means the angle over here will give us negative 90 degrees. And if you have positive J, you will have a positive 90 degrees. Okay, that's about the mathematics part, right? And if you would like to calculate the current, according to the question, we need to calculate the current. You will apply Ohm's law, where V divided by ZL. And remember, in the question, there is no information on what is the angle of the voltage. You can regard the angle of the voltage as 0 degrees. Okay, that should be enough. If you just put it as, for example, 10 degrees or whatsoever, that also can, because the question itself didn't state it about the the angle of the voltage. But normally, if the angle is not stated, we will regard it as a 0 degrees. All right. Now, same goes to the second question. If you look at the second question, an inductor is supplied 50 volt frequency of 10 kilohertz, passes a current of 7.96 with the angle of negative 90. Calculate the inductors. In this example, we just try to rearrange back our Ohm's law equation, where Ohm's law gives us V equals to IZ. And since we know what is the voltage value, and also we know what is the current in vector value, so we can always calculate Z, which is given by V divided by the current. And you know that since this is only an inductor, circuit consists only inductor. When you finish with this calculation, you know that this Z is basically the value of ZL, where ZL is given by JHL. Okay. The angle is okay. Okay, now, sorry, the angle J should be, all right, I did something wrong over here. Okay, look here. If you have voltage, the angle never mentioned, so we can regard it as 0 degrees. And if you try to solve this math, 50 divided by 7.96 is given by this value, and 0 divided by negative 90 degrees means that 0 minus 90, this angle should be a positive value. Okay, and this angle is, since this angle is a positive value, you can convert um, your what do you call it, impedance value as J 6.28 kilo ohm. And from this value, you can get back your inductor value, where you know that XL is given by 2 pi FL, and this value is known, this two value is also known, this value is known. You only need to get this L value and rearrange that one, you will get um, your inductor as 100 millihenry. Same goes to purely C circuit. Here for purely C circuit, I think this example you can always revise back the value, but the strategy that I would like to mention over here is that the important thing is that here we have a capacitor. For capacitor, we know that ZC will always be given by negative JXC. Okay, and this XC is always given by equation of XC equals to 1 over 2 pi F3. Okay, looking at the question, we have the value of C over here, capacitor value. You have the value of voltage without mentioning about the angle, means that the angle can be regarded as 0 degrees over here. And we have a frequency value which is 60 hertz. And in this question, we need to calculate the reactance of the capacitance and also the current flow. The current flow will be calculated using Ohm's law, basic Ohm's law, where V equals to V over Z. And in this case, Z is ZC given by this equation. So remember the difference between capacitor and inductor, where in inductor we see that um, ZL is given by JXL, positive over here, and XL is can be found by using this equation, 2 pi FL. For capacitor, ZC, due to capacitor, is always given by this negative JXC, where XC is slightly different with XL, where you need to to write or to find XC using this equation, 1 over 2 pi FC. And to find the current, just apply basic Ohm's law. This is example of RL circuit. In this example, we have a series resistance and inductance. The value of resistance is 7 ohm, and the value of inductors is 31.4 millihenry. And the value of voltage is mentioned over here, 100 with 50 hertz, and never mentioned about the angle. So the angle over here, we can regard it as 0 degrees. If the angle is mentioned, means that you need to put the angle value down here. Okay. The question asks about the current and also the phase angle. For the current, according to this equation, according to this solution, we will apply Ohm's law down here. Before we apply Ohm's law, you see here, we have to find what is the value of our impedance first. Impedance is given by Z equals to R plus JXL. Why we have R over here? Because this circuit is, if you read down the question, is consists of series between resistor and inductor. So before this, we only consider only purely other L circuit, purely inductor circuit, or purely capacitor circuit. But in this case, we have the combination of resistor and inductor. And you know that resistor always the value is ohm, and inductor value is inductor value or unit of inductor is millihenry. What you need to do, you need to convert this one into XL value, where XL unit is ohm. So based on these two, based on the conversion and combination of these two elements, it will give us the value of our Z or our impedance. And here XL as usual, given by 2 pi FL. And for RL circuit, always remember that for RL circuit, Z is given by R plus J XL. So here, the thing that should be highlighted here is the over here, where this is always a positive value. Okay, and when you convert from rectangular into a polar form, please note that your angle also positive over here. If you got negative angle over here, means that you do something wrong, whether here become negative or something like that lah. All right, that's for the current. For the phase angle, as I in my practice, to find the phase angle, I would like to, I mean, I always draw the Argand diagram to graphically analyze the vector of voltage and the current. So in this case, the vector of voltage, maybe I write in blue color. Okay, voltage here is 100 with angle of 0. So 100 over here with angle of 0. This is my voltage. And basically, maybe you would like, you were wondering what is the axis name. Axis, you can always put it as imaginary. This one is real axis. Okay, now voltage is over here. And the current, maybe we put it in green line. The current is negative 55.1. Negative 55.1 is maybe somewhere around here. And this is my current. So the phase angle, phase difference between voltage and current is basically this angle, is 55.1 angle, and without this negative value. Although the current angle is negative, but if the question asks about the phase angle, maybe this question is not fully written. Maybe in your assessment, you will write that phase angle of voltage and current. Okay, voltage and current phase angle is this angle, which is a is positive value over here, different between the angle of voltage and angle of current. So I think if you draw this vector representation, it is easier for you to really understand what is the phase difference between those two angles. This is very important for me last time lah. But for you, I think this is also something which can be used in order to get a proper understanding of relationship between voltage and current. Just draw the graphical representation vector current and voltage. Okay, same goes to in this example. In this example, we have in this case we have series resistance and capacitance. By right, if you draw back the circuit according to the question, we have resistor in series with capacitor. Okay, and the voltage over here, okay, we need to calculate the current, right? The voltage over here is 100 volts with frequency of 300 hertz, and never mention about the what you call it, the angle. So that's why here you see the angle we regard it as 0 degrees. And for the capacitance, it is given by the value of 10 microfarad. And the resistor here given by 7 ohm. You cannot combine these two unless you convert this one into ZC. ZC over here is given by negative JXC, okay, or the one that you see in this imaginary part of your impedance. And XC can be calculated using this equation, 1 over 2 pi F and C. Okay, if you put all the values over here, this is not L, this is supposed to be C. XC is given by this value, and put this value into the combination of resistor and reactance. So Z total impedance in series, we have two component in series given by R minus J X C. So here, the difference between what you have seen in RL circuit, for RL circuit, we have Z equals to R plus JXL. In RC circuit, you have R minus JXC. Okay. Now, for later on, after you finish with the impedance, you can calculate your current, which is given by this equation. This is basically based on Ohm's law. Given by Ohm's law. And after you use this equation to calculate your current, this is the value of your current stated as your answer. And before we get into the current thing, if you look at your impedance, okay, impedance here, we have combination of resistor and capacitor, and you know that for resistor RC circuit, we have R minus JXC. So here we have minus JXC, and a quick check for you is that the angle of your impedance always bring a minus value over here. If you got positive value, means that you did something wrong along the way towards the calculation. All right, we finished with the current. I've already mentioned about the effect of this impedance, and we try to get the current phase angle and the current phase angle. Okay. Now, if you would like to know what is the phase angle or the relationship between voltage and current, in this case, voltage is 0 degrees V, and the current you see here is positive 48, means that it's maybe somewhere around here. I, and this is the angle of 48 degrees that I mentioned just now. So for me, I think again, it is better that you redraw the graphical representation of voltage and current vectors in order for you to easily like evaluate what is the relationship between voltage and current. Okay, this is something which is you might see in your assessment. Combination of R, L, and C circuit. All right, before we get into this example, I think I'm gonna stop a while for toilet time. Maybe 3 minutes. We start again at 12:30. Okay, welcome back. Are you there?
Well, here, sir.
Okay, we gonna discuss this example. For those who don't have the link for the attendance, I've already uh, reposting the link. Please check the chat room. Okay, we proceed to our last example for this week, which is circuit. AC circuit consists of combination resistor, inductor, capacitor, and also another resistor which is in series within this circuit. And the example in this example, we need to calculate the current I of t. And since this is a series circuit, you need to remember that the current flowing through each of the element is the same. The value of current is given by this I of t. And for the second part of section A or part A, point number 2, you need to calculate the voltage across the inductor. Means that you need to calculate voltage over here. Okay, voltage drop over here. And logically, since you know what is the current, and to calculate the voltage, you need to apply Ohm's law, means that this inductor should be converted into this value, JXL. Okay, and later on, to sketch, you need to sketch the voltage and current waveform. This is a bit different from what we see in the vector or diagram or the phasor diagram. And finally, you need to draw the phasor diagram. This is like the thing that I said earlier, complete question. Draw the phasor diagram showing relationship between voltage and current. It's very clear what does we need to represent or we need to show. All right, before we get into the solution, please remember that we have various, or we have three main components over here. We have resistor, inductor, and capacitor. And in order for us to calculate this I of t, our strategy is by applying Ohm's law. I equals to V divided by Z. And Z over here should be consists of combination resistor R, and also we don't know yet whether it is plus or minus, and also the components of reactance. And this reactance X, we have two parts over here, two components. We have XL and also XC. And if you look at the circuit, we know that these two need to be converted into reactance value. So this capacitor will be represented by XC, and there is calculation where we need to calculate in order for us to get this XC as well as XL. So that's the idea of this example, and you will see that you will come across this kind of question in your assessment. Maybe it's a bit different. Maybe we have components in parallel, maybe, but this is the basic thing of analyzing using frequency domain for AC circuit. Okay, I've already did the calculation, right? Okay, this is what happened in your calculation, and I would really suggest that you follow this kind of strategy to give answer to your evaluator. Evaluator means me lah. For me to really understand what's going on in your solution, because like shock sendiri macam mana in English is like what do you call it in English?
Enjoy yourself.
Huh?
Enjoy yourself.
Enjoy yourself, right? Yeah, something like that. You you are the only one who know what is you try to explain in your writing. So that is not the case where in assessment. You need to inform the examiner what is this, and what is this. And then you need to inform the examiner, okay, this one, you should give me marks on this one, or you should give you should give me a mark on this one, like that. Means that if you have a circuit, please first simplify the circuit. A lot of students nowadays don't want to simplify the circuit. Maybe this is what the easiest simplification, or no, the what do you call it, simplest simplification. But basically, for during my time, last time, during my undergraduate time, I always redraw the circuit many times. For example, this maybe the first time, the first thing I would draw is like this box, and like this box, and later on, okay, this is my voltage lah, for example. So this is 60. This 60 coming from what? Coming from um, 10 plus 50 equals to 60. Although it's like a simple thing, but sometimes it helps you in order to get marks. For example, okay, 60, okay, I got the 60 based on this calculation, 10 plus 50. Okay, later on, this is what? This is XL. Although it's not, I'm not mentioning my value yet, but in my diagram, I've already indicate where is my XL, where is my XC. And finally, maybe I combine my impedance to be like this. So that's the thing that I would like to comment first before we get into details on the calculation, because it is very important for you to get marks. I know that your calculation sometimes correct, but what happened if you did some error, or you miss something in your calculation, and of course your answer will be incorrect. And how I'm gonna give you marks if you only give me your final answer? You don't show me the equation, you don't show me the what you replace in the equation. How do I give you marks? So that's the things, and which is sometimes not really significant, but sometimes it is important for us to tell the examiner what's going on in our solution, and guide the examiner for us to get extra, not extra lah, give us marks since our answer is incorrect at the end. Okay, anyway, that's some advice for me. Anyway, for this example, our main objective is to find the current, to find the voltage across this inductor, and we try to draw the waveform of voltage and current and phasor diagram. This one you don't have to write lah, because this is something, this is solution that I want to show you. But normally in your solution, please feel free to redraw back your circuit in different arrangement, or in simpler arrangement. Simplifies your circuit, in other words. All right. Anyway, to solve first question, I of t. You know that you knew that to get this I of t, you will apply Ohm's law. And in Ohm's law says that V equals to Iz. Here, see here. V equals to IZ. And in order for us to calculate the current, you need to get the value of impedance, as well as you need to first analyze what is your voltage angle and also voltage in the form of in phasor form. So the first thing that I did over here is that I must write my voltage in phasor form first. Okay, if you would like to write down your voltage in phasor form, there are two ways that you can do that. First, maybe using the peak value over here, just put it like that, or you can always use this value, or this is known as RMS value. Okay, in calculation, it's fine using this peak value in manual calculation, but in practical, if you would like to compare your practical measurement and also your calculation, what you need to do, you need to consider this RMS influence. Okay, but the rest of the calculation is using the peak value over here. This is just a reminder for you guys. Whenever you try to compare your measurement in practical and also your calculation, make sure you consider the RMS as well. All right, impedance. Impedance here is the combination of R, L, then C. So it means that our final value of impedance may be, or not maybe, should be based on this equation, Z equals to R plus minus JX, and we don't know what sign is should be over here unless until we finish up the summation, or where we add those two XL and XC. Before we get into that one, we need to find what is XL first. XL is given by 2 pi FL, and in this example, you don't need to calculate your frequency value because it is given here the value of omega. Just use this omega and multiply it with your inductor value, you will get your XL value as 35.8 ohm. And for XC, same goes to XC. Don't need to find what is the value of frequency because here omega is given. Now for XC is given by 1 over 2 pi FC, or 1 over omega C. And the value here is 55.9. If you look at the value, yes, it is positive value. Both are positive value. However, if when you try to combine these two values, okay, it should be the XC is given by ZC, basically is given by negative JXC. So that's why here we have XL minus XC. And when you minus and when you subtract these two values, XL and XC, at the end you will get your Z value as this 60 minus J 20.1. And from this value, 60 minus J 20.1, I know that this Z is basically consists of R minus J XC. This is RC, and towards the end, if I try to calculate my current, I know that my current will always lead my voltage by this 18.51 52 degrees. Maybe at the moment you don't understand what I'm talking about, but please please remember that since this sign is negative, means this Z or this impedance is most likely the combination of resistor and capacitor, because resistor value here, or the capacitor influence is a lot more higher compared than inductor influence, inductor value of reactance over here. reactance of capacitor is greater than that. So it's like this is mainly due to R and C circuit. All right. This is Z in rectangular form, and you can always write in polar form, whether using this value or using this value. But I would suggest you use this negative value because it is easier for you to later on analyze what is the difference, the phase difference between voltage and current. And as usual, to calculate the current, we use Ohm's law. And when you try to write down in a sinusoid form, here, the angle should be here. The current magnitude should be here. And as I mentioned earlier, if this is sine and you did nothing in order for you to like convert it into cosine or whatsoever. So make sure your current also in sine wave as well. All right, that's for question number A1. And next is for A2. Okay, look here, I redraw back my circuit. And in this, in order for us to calculate the voltage across the inductor, as I mentioned, if you know what is the current over here, multiply with this JXL, you will get the value of voltage across the inductor. And VL is given by I times JXL. Why we need to include J? Because I here is a vector, means that Z over here should be a vector as well. So since we are focusing on this part, means we only use this equation, JXL. And here I put some additional calculation in case that you need to calculate the voltage across the capacitor, but not asked in the question. But here I just put the solution of in case if you need to calculate voltage across the capacitor, what you need to do, you need to use Ohm's law. And here for the Ohm's law, the Z you were applying is negative JXC. So here, negative JXC would represent the one over here, or the component of capacitor. And the component of capacitor, negative JXC, is given by negative J55.9. And if you convert it into a polar form, it is 55.9 with the angle of 90 degrees. This should be Ohm. And apply Ohm's law, you will get the voltage across the capacitor and the angle of the voltage itself. Okay, to solve question number B, question B, you need to draw the waveform of voltage and current. To draw the waveform of voltage and current, please rewrite back the voltage in polar form and also the current in polar form as well. So here, this is the reference that you need to follow in order for you to draw the sinusoid waveform. Since the angle is 0, means that you will start here at 0 and then make a sine wave over here. And for current I, since it is 18.52 degrees, means that it will start earlier than this 0 degrees. The current is over here. I don't mind about the magnitude over here, but please label the magnitude. The magnitude should be 120 for V of t and 1.896 for the current. Although you see here the scale is maybe it's not consistent, but as long as you label your magnitude, the maximum value of your waveform, then that should be fine. And also, the another important thing is the angle. Please label the angle over here. You can label it like this, or maybe you can put it like this point is 18 point, like 18.52, for example lah. But I think since the space here is not enough, better you put it like this way. Okay, and the last part, is to draw the phasor diagram. And again, for phasor diagram, I would recommend you guys to use this kind of graphical representation. I believe it is easier compared to what explained in the textbook. The thing explained in the textbook also true, but the one here is more direct and also easy to understand. Okay, to draw the phasor diagram, you also need to consider these two equation, voltage and also current in its vector form or in phasor form. The voltage is 120 degrees with 120 volts with the angle of 0 degrees. Means that you're going to draw the straight line over here representing the voltage, and for the current is 1.896 with angle of 18.52. Again, I don't mind about the magnitude over here as long as you label this one is I, this one is V, and it is logical that V should be longer than I since V is 120. And one more thing is about the angle you represented here. Although I know that this angle is not 18 degrees, this angle is around maybe 30 degrees, 40 degrees, or 45 degrees. However, I don't mind about that as long as you label this one, okay, this theta is actually representing 18.52 degrees. That should be enough. And if you, if there's question asked about phasor diagram showing the relationship, and basically it's not complete until you get into this statement. You need to write down this statement where here it says I lead voltage by certain degrees, 18.52, and V always lag I by 18.52 degrees. And if the question asks about which one is leading, voltage or current, so maybe we can say that I is leading, okay, with respect to voltage. All right, now return back to what we have learned before this about the word CIVIL. Okay, and remember that I said here my Z is most likely based on RC circuit because my Z is given by some value, R value, plus, minus J some value. The minus here, okay, the minus sign over here tells me that this is RC, more towards RC circuit. C is more dominant compared to inductor. So we can consider as RC circuit, although it's a combination of R, L, and C, but C is more dominant compared to the inductor. So that's why we get into this conclusion. And since this is RC, return back to this word, so I would focus on these three letters, CIV. And again, if I try to check back my answer, okay, my answer tells me I lead V by 18.52 degrees. So if I have RC, my answer should be this definition. So if C, I should come before V. So I lead V. It means that my answer here is correct. So that's how I check back my answer. I don't know how you try to quickly check your answer, but this is the way I quickly check my answer, whether it is the not exact answer, but the strategy that I use here is correct or wrong. Okay, because based on this definition, this word says that C, if I have C is more dominant, for example, I have C circuit, purely C circuit or RC circuit, I must lead voltage or voltage lag current. So my definition here and my phasor diagram here means it is correct lah. Okay, that is how I learn about how to quickly check, not the value, the exact value, but the general idea of my solution, whether it is in the right direction or in the wrong direction. And maybe you can learn later on by yourself, or maybe you have your own strategy or your own style in order for you to quickly check your answer. Okay, I think we are towards the end of our lesson, and in summary, we discussed about more on examples of analyzing RLC circuit, as well as in general is AC circuit, and we also learn about more about phasor diagram and also RMS in this class. Okay, next topic is very is considered harder than what we've seen today, so make sure you do some revision back on nodal and mesh, how nodal and mesh is calculated, and in general for nodal we try to set up using Kirchhoff current law at the nodes. For mesh we try to set up Kirchhoff voltage law around the mesh. Okay, I think that's all for today. You have any question so far? Have any question?
No.
Okay. Before we leave the
Buka kamera.
yes. Thank you. You need to turn on your camera, and I try to snapshot.
Baju basketball orang.
Okay. Right, I cannot snip. Oh, over here. All right. Thank you so much for your attention. I don't know whether it is you can capture all